Hello and welcome to another video. In this video, we're going to be working on design a food rating system. And in the problem, you are designing a food rating system that can do the following: modify the rating of a food item listed in the system, and return the highest rated food item for a certain type of cuisine. So essentially what's going to happen here is you will have food items that will have a type of cuisine, and they'll have a rating. And then we want to be able to modify that food item, and we also want to return the highest rating for a type of cuisine. So let's walk through this. We have a constructor that can initialize it, so the food items are described by food, cuisines, and ratings. So basically you have three arrays, and you have matching elements. So you'll have like a food array, a cuisines array, and a ratings array, and everything at the same index, like the food at index I will be in cuisine at index I, and it will have a rating of index I. And so here they show you that. And you can also change the name of the food item. And yeah, you want to return the highest, you can't change the name, you can change the rating of the food item. And you want to return the name of the food item as the highest rating of a given cuisine. If there's a tie, return the item with the smaller name. And smaller name just means alphabetically, like comes first in the alphabet. So let's walk through this example, kind of a big one. And actually what we can do maybe is we can like move stuff around. So let's move this down here, let's move this over here, and let's like draw out our food maybe, and our cuisines and things like that. Actually, let's have this example here. Let's just get rid of this for now, because we don't really need it. So let's walk through how we're gonna show this. So maybe we'll like group it in cuisines, let's say. So let's take a look. So first we initialize it. So we have kimchi, which is a Korean food, which has a rating of 9. So maybe we'll have like categories. So I'll have a Korean. One of them is going to be kimchi with a rating of 9. And then let's keep going. So we also have a miso, which is a Japanese food. So Japanese, say Jap. And it has a rating of 12. So let's say miso, 12. Maybe we could make this like KO or something. Okay. And then we have sushi, which is also a Japanese food, so we will add it over here with a rating of 8. So sushi with a rating of 8. And then we're going to kind of try to figure out like what's the best way to represent these things. So then we have moussaka, never heard of that one, which is a Greek food. So it's just a GR. And it has a rating of, let's take a look here, 15. So let's just say, yeah, Osaka, it's rating 15. And what else do we have? Ramen, which is a Japanese food with a rating of 14. So let's just say like ramen, rating 14. And then finally, we also have bulgogi, which is a Korean food with a rating of 7. So bulgogi, rating 7. So here we go. So these are like all of our categories. And this way we can easily view things, and then we're going to figure out how we're actually going to represent it. So we're not going to necessarily represent things like this, but this will help us visualize everything a little bit easier through this example. So if we want to get the highest rating food for Korean, it's going to be kimchi, right? The highest rating. Then highest rated Japanese food is going to be ramen. Then we want to change the rating of sushi to 16. So what would happen here is we'd have it in here, and we change it like this. And that's it. So now highest rated Japanese food will be sushi, and change rating of ramen to 16. And then highest rating Japanese food will be ramen because they are equal, but you want to return the smallest one alphabetical. So that's kind of the idea behind this problem. Now let's actually delete this because we don't need it anymore, and let's take a look at the constraints. So here we have n equals 2 times 10 to the 4th. So essentially we will have 2 times 10 to the 4th food items. They'll consist of lowercase letters, and each item will have 10 letters or less. You'll have a rating between 1 and 10 to the 8th. All the foods are distinct. And you will have at most 2 times 10 to the 4th calls in change rating and highest rating. So let's just think like these can get really big, right? Like imagine your cuisine has like 1 million items. How would we change a rating? And how do we get the highest rating? It's going to be very tricky, right? Like like, let's say we just have some of these, like, let's say we have these in assorted order. Well, what if I change ramen's rating to like 8? Like, how would I do this, right? Like, if I change ramen's rating to 8, how would I know what the biggest thing is now? Let's say they were in assorted order. It would be really hard, right? Because you can't move it, because if you move it, like, let's say I move it and I'm like, okay, well, this is not the biggest anymore, maybe I'll just like place it in assorted order. So if that's the case, if you just find it, let's say you can even find it in ov1, like you just know where it is, you find it, you move it in assorted order, that would be an ov-n operation, right? Because you'd have to like remove it from the middle, add it to the front, the back, somewhere, put it in some location, and then move everything else. So that would be ov-n. And the problem with that is if you have 2 times 10 to the 4th calls, and this is also good practice to start doing for medium and hard problems, figure out like what's your algorithm and will it actually work, and you should be able to base it off the constraints right away. So if you have 2 times 10 to the 4th calls, 2 times 10 to the 4th calls, which will be like, you know, let's say most of your calls are just change rating. Like half your calls, let's say, are just like adding a bunch of items to one cuisine, and then the other calls are just change rating, something like that, right? And then you'll also start out with 2 times 10 to the 4th items. Basically, let's say half of these are in one category, and and half of your things are just change rating of that thing. Or not even that, you can have more, right? So it would be something like this. It would be like 10 to the 4th times 10 to the 4th, basically, which would fail. It would be like 10 to the 8th. So we can't really have we can't have a linear time change rating. We need to do better than that. And so how would we do that? That's the question, right? And so it's okay to have like some ratings be like kind of slow, right? Like it's okay to have like maybe sometimes your change rating will be slow, but then most of the time it should be pretty fast. You need to have like logarithmic or something like that, right? And so the idea with this, first of all, we need to figure out what to store. And the idea with this is kind of tricky, to be honest. And I haven't really seen too many algorithms that use this. But what do we first of all need to store, right? Like, let's just think of some things. So in order to change, because we need to change the rating of a food, right? Like we're given some food and we need to change rating. We need to have some kind of mapping from food to rating, right? So from food to rating, we need to have some kind of mapping. And we probably also need to have a mapping from food to cuisine, right? Because like let's say we're asked to get the highest rated food or something. Well, how would we know where that food is? So we probably need to have a mapping of food to rating, and then we probably want to have a mapping of food to cuisine, because if we change that, especially also, like let's say what happens, like another reason why we need to have a mapping of food to cuisine is if we change a food's rating, we also need to like know where it is in the cuisine to change that rating, right? Unless we just have like a bunch of foods, which would be kind of weird, right? Like in a cuisine, if we just have a bunch of foods, like how do we even get the max rating? Do we just like iterate through all of it? So what we really need is an object that has food ratings, right? So it'll be like, you know, kimchi or something with a rating like 9 and so on. So that's one of the things we need, is a food rating. Second thing we need is, like I said, we need to have a food and cuisine. And this would just be like, you know, let's say this is like kimchi. Okay, so this would be like kimchi as a key, and then the value would be like Korean or something. And then what we need to figure out is for this cuisine, and this is what we need to really figure out is, why does it do, okay, there we go. For cuisine, we need to figure out like store some kind of data structure where we can get the max, right? Like, how do we do that? Do we just have a sorted list? Like, what do we do? And you might think, another thing you might think is like, okay, well, what if I just have like a heap? And for a cuisine, I can just have a heap of items, right? So we have a heap, and then we'll have, like, let's say for this, like, let's say we just have a max heap, right? And our max heap, for, let's say for Korean, is something like this. We can just be like, okay, well, we can just get the topmost element from the max heap. But what if we change the value of one of those things, right? Like, what if we change the value of some random item in the middle, like miso? What if we just change the value of miso to like 35? Then, first of all, we need to know where our item is in the max heap, which is kind of hard, right? Like, we know our food is in the cuisine, but where it, well, like, what index is it in? Then we also need to heap pop it, and then we need to heap push it. So that's kind of, like, it's very hard to do all these things quickly. Like, know the location, and, like, know where to put it, right? So that's kind of the idea. Because it's very hard to do that, we're going to have kind of like a tricky little algorithm. And essentially what's going to happen is, let's actually move this down. So let's say we have these items. We will actually have a max heap. So we will have a max heap of, and in Python, you can do like some tricks to make your max heap a min heap and so on. And I'll kind of describe that as well. So let's say like we want a max heap, and if for Japanese food, it's going to be in this order, right? So something like this, and then this, and then this. And then for this is fine, and this is fine. So this would be our heap. And now what we do is, instead of actually, when we change an item, like when we have this food and rating, if we want to change the rating of, let's say, kimchi to 25, instead of finding it in here, we don't need to actually find it in here. What we're going to do instead is we're going to change the rating in our mapping here, like in our food to rating. And then we're just going to put that item into the max heap. So we'll just put in, we'll also use the category, right? We can use the category to figure out like what category to put our kimchi in. And then we can say like, okay, well, we can just throw in kimchi here with a rating of 25. Now this won't always work out where it's the biggest element, but essentially what we're going to do is every time we change a rating, we will put in that thing again. And then what's going to happen here is when we're looking for a max, we will just check, is the max element actually the current rating of the item? And so the heap will have ratings and food, and some won't be current, right? So you'll just have a bunch of like outdated ratings. And we can just check the max element, and if the max element is current, then we can return it. And if it's not current, then we can pop it. So we're kind of doing like a update as we go. Like we're gonna look for a max rating, and we're gonna update as we go. We're just gonna check max ratings and see like, is this current? If it is, okay. And there still might be a bunch of like other outdated elements, but that's totally fine, because now we're gonna bring down our complexity. So if you think about it here, if you can only do 2 times 10 to the 4th calls into this, that means this heap, the max size of the heap is going to be like 2 times, or it'll be like, let's say like it starts out 2 times 10 to the 4th, it'll be like this, right? Like let's say everything is in one cuisine. And then worst case scenario, the thing is like, even though some operations might be n log n, like let's say in one operation, you actually have to delete half the heap. So that would be n log n, or, roughly. But then, so let's say you have 4 times 10 to the 4th items, but then what would happen is, if that would happen in one operation, then in the next after that, everything left in the heap is current. So you can only have 2 times 10 to the 4th items that are outdated. So this together, like every single access together will be n log n. And that's why this will pass, because it won't be like, we keep accessing outdated elements. We are essentially getting rid of outdated elements. It's kind of similar to like union find, where you do a find and then you essentially update your path to make it faster. This is kind of the same idea. We will have a heap with a bunch of outdated stuff, and as we process it, we'll get rid of our outdated stuff, so we don't keep looking at outdated items. So the most we'll ever look at outdated items once, meaning this will be the time complexity, of this, like of every single highest rated or change rating operation. So basically, let's kind of walk through some examples here. So let's say instead of this, let's say we change the value of kimchi. Instead of to 25, we change the value of it to like 2. So what's going to happen is we're going to put it into our heap somewhere, right? We'll just insert it. And what's going to happen here is we're going to check, okay, what's the max element? It's kimchi with a 9. But our current rating of kimchi is actually 2 because we changed it. We're going to change it in our dictionary. Then what's going to happen here is we're just going to pop this. And then we're going to check, okay, is bulgogi the right rating? If it is, we'll return it. And if bulgogi is updated as well, or outdated as well, then we'll pop that as well. And then we'll keep doing that until we hit a max element that is not outdated. And that's kind of the trick to this problem. It's pretty rare to see heap use in this way, where you just have a bunch of outdated elements and you just like, you just get rid of them as you go through them. But that's kind of the idea. So we'll have, like I said, we'll have three things. We'll have a food with a rating. We'll have a food with a cuisine. And then we'll have a cuisines heap where the items will have a rating and they'll have a name. Now we also got to take care of, and this is particular for Python, in other languages you can make a custom comparator. There's a few ways to do it in Python, but essentially, because in Python there's only max heap, so the way we want our things to be sorted is we want two ways of sorting, right? We want biggest rating first, and we want smallest name first. So how do we handle both of these, right? Like if you only have access to min heap in Python, so if you use heaps before, the first part is pretty straightforward. We can just make all our ratings negative, right? So if it was like this, instead of inserting things like this, first of all, we will insert by rating first, because that's the main thing we want to look at. And if there's a tie, then we would go by name. So our ratings will be like this. Let's say for like, let's just show for a Japanese food, we can get rid of these. So this will be like one category. So our stuff will be like this, and our ratings will be negative, and therefore when we get the max item, it'll actually be the min item. So we can just get the rating here, and then we store every rating as negative, and then once we pop it, we just make it positive. So that part's taken care of. And the smallest name first is actually taken care of automatically because Python sorts string lexicographically increasing anyway. So if you have two things with the same name in a heap, or with the same value, the one with the name that comes first in the alphabet will appear first. So that's already taken care of for you. So all we have to really do is just flip the ratings to negative, and then the name part is taken care of for us. So kind of tricky for sure to make it pass, but yeah, essentially that's kind of the idea behind it. And this will be useful for other problems, to have this kind of heap stuff where even though you might think like, oh, you know, I'm like making my heap bigger, how do I make it sufficient? The thing is, all your redundant items get thrown away as you pass them, so you only look at them once. Kind of like it's also kind of like a stack, right? Where like an item will only get put in once and removed once. So that's kind of the thing. Even though we have 2 times 10 to the 4th calls, we will only have 2 times 10 to the 4th redundant items, and we'll only look at all of those one time. So that's why it's going to easily pass. Okay, so now we have everything we need, and we can code it up. So remember, we're going to have 3 things, right? We're going to have ratings. So let's write that. So we'll have self.foodRatings dictionary, and we will also have self.foodCuisines, right, where we want to map the food to the cuisine, so we can figure out like where it is in the cuisine, what cuisine it goes into, and so on, and when we change the ratings. And then we also want to have cuisines, which is going to be the dictionary of heaps, right? So we'll have a key of cuisine, and then the value of a heap. This will make a default dict. Everything else is going to be fine like this. It's just going to be easier to do this in a default dict. Now, essentially, what we have to do is we have to loop through foods, cuisines, and ratings, and for everything of the same index, we have to fill out all 3 of these. So we can just use a zip in Python, or you could use like a for range loop and just go through the same index. So we could say for food, cuisine, and rating in zip, foods, cuisines, and ratings. And what zip will do is it will just zip everything up into like a bunch of tuples. So like if you have something like 1, 2, 3, let's say, and then you have ABC, and then you have like DEF. For everything at the same index, it will just put it into a tuple, so you'll have like 1AD, 2BF, or 2BE, and so on, right? So everything at the same index will just get turned into a tuple, and then you can iterate through. Okay, so what we have to do is we have to, in the food ratings, we have to put the food and the rating, right? So we could say self.food ratings of the food. It'll have a rating. Then self.food cuisines of the cuisine. Actually, for this one, yeah. So food cuisines is going to be food mapped to cuisine. So it'll be food mapped to cuisine. And now the last part is we have to have this self cuisines, right? So this will be self.cuisines, and this is why the default dict is going to be useful. We can just heap push to it, and if it doesn't exist, it'll just make an empty list. So, or you could say like if the cuisine is not in here, make an empty list, then heap push to it. If you don't want to use default dict, it's totally fine too. So we were going to heap push to this, and if this doesn't exist, it'll make an empty list. And we want to push at key cuisine. And the thing we want to push, remember, is a negative rating, because we only have access to min heap, and then we're just the food. So that way, the biggest rating will be the smallest, and then the food is automatically in increasing order. That part is sorted correctly. There is probably like other things you could do. Like let's say you wanted your foods in reverse as well. There's like other things you could do with the food. Like for one thing, you can just get like an ASCII value for your food as like another variable in here. So you could have like food ASCII or something, and then you could put that negative, like negative food ASCII or something, where you just like take every single character in here and like add it together, and you give more priority to your characters that are farther up or something. So there's like a bunch of tricks you could do, but we don't need to do it for this. Okay, so that's going to be our constructor. Now change rating is going to be really easy. So in the change rating, first thing we have to do is we have to change the actual rating in this food ratings, right? So self.food ratings food. We have to update it. So we can just make it the new rate. And remember, we want to keep these as negative. Did I actually do that here? Yeah, we want to keep these as negative. Because when we look through our min heap, we need to check if the rating is equal to the food and food ratings. So we're always going to store the ratings negative, and then when we return the item, actually, we don't even need to change it to positive because we're only returning the item name. So we're just always permanently storing the ratings as negative. Okay, so now what we need to do is remember, once we have this new food with the rating, we're going to add it to our heap, and then the item that is in there already will be redundant. So every time we update, we just add to the heap. So we can heap push to self cuisines. And this is also why we need that cuisines mapping, right? We need to know what cuisine the food is in. So this is where we find that out. So we'll say self.food cuisines food. Right? We need to figure out what cuisine to push to, and the value we're going to push is going to be the same thing, right? New rating and the food. So even though it already has one, we'll push an updated one, and we're going to be able to check if it's updated because this food to rating will have the newest state. So we can always, whenever we look at the heap, we can just check, like, is it the updated rating? If it's not, get rid of it. If it is, give me that value. Okay. So that part is done. Now we need to do the highest rated. So essentially, first we need to figure out, like, what heap to look at. And that's just going to be the heap in the cuisines, right? So self.cuisines cuisine. And essentially what the idea is, we need to look through the heap. So we're going to say, while heap, we need to get the max rating, which will be the min value. We need to check, is it outdated? If it's outdated, pop it. And if it's not outdated, then give me that value. So we'll say, remember, the format in the heap is going to be negative rating and food. But we can just get the rating because we are storing the ratings negative already. So we can say rating food equals heap 0, right? Just look at like the first value. Don't pop it yet. Only pop it if it's old. If it's new, if it's up to date, just give me the value. Because like if you're getting the max, you don't need to pop the max. You just need the max value, right? So we can say if self.food ratings of the food equals the rating, that means this rating is up to date. So that we just need to return that food. Otherwise, and we're guaranteed to have an answer here. So otherwise, we're basically saying, okay, this max is outdated. So let's just pop it and let's try again. So we'll just heap pop here. And that should do it unless I screwed something up. So let's find out. Okay. Self.food, is it food rating? Let's see. Self. Goes to rating. Let's see what error we have in here. Rating is not defined. Oh, this is rating. There we go. Okay. Yeah, so you can see it's pretty efficient. Once again, you can kind of see this like chart where like everyone's in the same category, so everyone's gonna have like roughly the same kind of thing. I think when I ran it a bunch of times, I did get like super fast before, and then like some just goes all over the place. But essentially, let's go through the time and space for this one. So let's make some parameters maybe for this. So let's say C is the number of categories, and then maybe like F is the number of foods. I think that's about it. So let's figure this out. So essentially, when we put our items, when we put our foods in, like all our foods can be different. So that's already O of like F, let's call it, right? And then let's also define like another field, maybe like the number of foods in a category or something. So let's call that like n or something. Okay, so when we put the foods in and and we push these foods into the cuisine, so actually this is going to be worst case n log n, because if every single category is the same, then that means you're going to be pushing all of your foods into the same like category, which will be n log n. Yeah. So the time here is going to be like the number of foods in the category, which will be like n, and then you have to do, so it'll be something like this. Yeah. And then the change rating is O of pretty fast. That's just a log n. So that's going to be less than this. The initialize will take a lot longer, worst case. And then highest rating, essentially what's going to happen here is we're going to look at a category, and worst case scenario, we have to pop like all of the items. So I think it'll be something like this again. Yeah, because if we look through one category, let's say a category does have like 4 times 10 to the 4th items, and half of them are outdated, right? Like literally we just say like, okay, like we put in 2 times 10 to the 4th items, we give them all a count of like 5, then we update them all to 10, and then what's going to happen here is in one highest rated, you will have to pop off 2 times 10 to the 4th. So I think time is actually this for this as well, where basically the number of foods in a category is what really you're capped by, and these other things are not as important. Yeah. Now, obviously, like if the number of foods in a category is really small, then it's going to be, so I guess maybe we can write it like this. This might be a little bit better, because let's say number of foods in a category is like 1. Then this is going to be basically 1, but you can still have like a billion foods, right? So maybe this is a little bit better way of writing it. But either way, this is fine. And then space. So we can look through all of our things. So our foods will have O of F. Our categories will have O of C, which will be upper bound by O of F. Technically, you can't have more categories than foods, right? Because like a food can either have its own category, or yeah, you can't have more categories than foods. You can only have more foods than categories, because every food has to belong to a category. So that's just capped by O of F. And then every category has some number of foods in here. Like the heap part is going to be O of n, but n will also has to be smaller than the number of foods total. So I think the space, just the number of foods total, is your upper bound. Yeah, and I think that's going to do it. So hopefully this is helpful. Definitely kind of weird with this whole heap and getting rid of redundant information, but kind of a cool problem. I think it was a good one. Nice not to have an easy problem. So hopefully you guys enjoyed it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.